All right, here we are at Lipan and Navajo viewpoints on the Grand Canyon South Rim field trip. We're going to be looking at the Grand Canyon supergroup in some detail and how it relates to the Paleozoic deposits on top of it by way of the Great Unconformity here, and some nice views of the Butte Fault to kind of emphasize again its importance in the evolution of the Grand Canyon. So here's a satellite view. Let's zoom in on approximately this area to see where we are. So again, here's the road which takes you around the rim and out towards Cameron and eventually Flagstaff. Lipan Point is located here and Navajo Point is located here. And in both cases, we're going to be seeing images off to the northwest approximately. Again, the satellite view is very telling of the difference in rock types we're going to be looking at. All of this red and black stuff here is the supergroup rocks, namely the Dox Formation and the Cardenas basalt on top of it. And off in the distance here, we'll be seeing all of this kind of green and brown and whitish stuff is the Paleozoic rocks. Let's take a quick look at the geologic map in cross-section. So again, here we are at Lipan Point, looking that way, and we'll be here at Navajo Point, also looking that way. Geologic map is also separated by color. By and large, all of these rocks down here are the Grand Canyon supergroups. The grays here are the Dox Formation, overlain by the Cardenas basalt, which is this pink one. And from this rock type here, which is not as obvious here, is the Tapete Sandstone. That's the base of the Paleozoic sequence. And all of this stuff kind of above that layer is the Paleozoic, all the way up through the lightest blue here, which is the Kaibab limestone. So in terms of the cross-section off to the right, we're going to be seeing roughly the middle to uppermost part of the Proterozoic sequence of the Grand Canyon supergroup, and then we'll be seeing the Great Unconformity, especially as it's an angular unconformity, as you can see here, and then up through the top of the Paleozoic sequence. Panorama here from left to right covers about 150 degrees in terms of view. But what I want to do is zoom in on this area approximately, which is located here, and talk about the supergroup rocks and the overlying Paleozoic rocks. So what we have here are the gently tilted off to our right towards the east and northeast of the supergroup rocks. This unit is the Dox. Actually, this is Dox down here as well. This is the Cardenas basalt, and above that is the Nankoweap Formation. These are gently dipping around 10 to 20 degrees or so, depending on where you are, off to the northeast. This dip occurred when these rocks were tilted during extension and breakup of Rodinia at the end of the Proterozoic at about 750 million years ago. Overlying them are the flat-lying Paleozoic sequence. What I'm drawing here is the boundary between the Tapete Sandstone, which is that flat-lying unit just above this red line, and the underlying Proterozoic supergroup rocks. And these rocks are nearly flat-lying. They're not perfectly flat, but they're very close to flat, just a few degrees of dip, depending on where you are. So what we have here is a great example of an angular unconformity. This is where we have a series of dipping sedimentary layers, and the basalt layer in there too, of the Cardenas basalt, overlain by the flat-lying Paleozoic sequence. Okay. In the eastern part of the canyon, the Great Unconformity is an angular unconformity. In the western part of the canyon, where you can't see in this image, but I'll draw it anyway, the boundary is a roughly flat surface separating the metamorphic rocks, which have igneous intrusions in them, from the flat-lying Paleozoic sequence. Here, this surface is a nonconformity, where it separates the sedimentary layers, the approximately flat-lying sedimentary layers, from a different type of rock, namely the metamorphic and igneous rocks that underlie it. But what we're seeing here is one of the best examples in the world of an angular unconformity. Let's move over to Navajo Point, which again offers really spectacular views, especially those looking up the eastern part of the Grand Canyon. So let's zoom in on roughly this box, and that's what we see below. And again, another good example of the grade unconformity as an angular unconformity. So what we have in front of us is again the Docks Formation. I'm just drawing in some lines to kind of indicate the dip. It's dipping off to the east and northeast, overlined by the flat-lying Tapete Sandstone. And so again, I'll draw the line representing the grade unconformity. This is a boundary between these dipping layers. It's not quite as obvious when you look on this side because the rocks are dipping to the east. But nonetheless, it's the same thing. Here we have the dipping Proterozoic supergroup rocks. For example, here's the docks in front of us, overlain by the Tapete Sandstone, and then the rest of the Paleozoic layers above it. From here, we can also get another good view of the Butte Fault and some evidence of how motion on that Butte Fault led to the distribution of the rocks we see here. So let's take a zoom in on an area roughly there. Here it is. So notice the boundary here between the Chuar group, supergroup rocks, where they are adjacent to the older Cardenas basalt. Whenever you have rocks of different age touching one another, some of those rocks had to move in order to have them adjacent to one another because they form in horizontal layers, youngest on top, oldest on bottom, so some faulting event had to move to bring those different age rocks in contact. So this occurred when the Butte Fault was a normal fault during breakup of Rodinia, so the rocks on the left of the Butte Fault moved down relative to those on the right. But subsequently, the Butte Fault has been reactivated as a reverse fault, and these rocks then have been moved up relative to those on the right. And evidence for that reverse fault activity is readily apparent back here. So let's zoom in on that area. And here we are. Here's the trace of the Butte Fault, and it goes off the picture to our right, and then it follows back this way off the picture to our left. And most recently, the rocks to the left of the Butte Fault have been moved up in a reverse fault relative to those on the right. And you can see how the rocks on the right were deformed as a result of that motion. So imagine taking these rocks and trying to move them up a surface like this. The rocks on the right were drug up and deformed and folded in the vicinity of the fault. In fact, the trace of the Butte Fault right here is really the top of the red wall limestone, which is more or less flat here, but then is bent upwards like so, just like you can clearly see in these layers above. You can also see this quite clearly in a number of spots from the North Rim field trip, and so if you haven't seen that one already, go take a look and you'll see another set of great examples of evidence for activity on the Butte Fault. All right, thanks for listening, and I will see you soon.